Section 2.3, solving right triangles. In this section, we'll look at the definition of the significant digits and use definition 2 of the trig functions to find the missing parts to some right triangles. Significant digits or SD. The number of significant digits or SD is a number is found by counting all the digits from left to right, beginning with the first non-zero digit on the left. When no decimal point is present, trailing zeros are not considered significant digits. Let's look at the example. For the number 0.0420, the first non-zero is the number 4, and then count from that number from the left to the right. So 1, 2, 3. So therefore, there are 3 significant digits. The second number, 0.0004. The first non-zero is the number 4, and that gives you the only one significant digit. The third number is 200, and with the decimal point, counting from the first non-zero and all the way to the decimal point, there are 3 significant digits. The last number, also the number 200, but no decimal point is present. That would be the case that no decimal point is present. So trailing zeros are not considered significant digit. Therefore, only the number 2 is counted as the significant digit, or there is only one significant digit for the last number. The accuracy of size versus the accuracy of angles. If the accuracy of the size is 2 significant digits, the accuracy of the angle would be the nearest degree, or no decimal place. For 3 significant digits accuracy of the side, there is 1 decimal place, or nearest tenth of a degree. For the case of 4 significant digits accuracy of the side, there will be the nearest hundredth of a degree, or 2 decimal places. Let's look at the example. Use definition 2 to find the missing parts to some right triangles. Recall the definition number 2 to find the trig function based on the right triangle, an angle theta, and identify the opposite, adjacent, and hypotenuse sides on the right triangle. Use the definition staccato R, or sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. The tangent is opposite over adjacent. For this right triangle, ABC, with an angle C is 90 degrees, part A, and angle A is 36 degrees. Part C, or the side C is 11 centimeters. Find the side A, side B, and an angle B. So 3 pieces are given, and find the missing 3. From the right triangle, we have an angle A, 36 degrees, which is the accuracy of the nearest degree. Okay, therefore the size will have the accuracy 2 significant digits. So the answer for A and B will be 2 significant digits, and angle B would be the nearest degree. To find an angle B, from the definition of the right triangle, the sum of all angles, the A plus B plus C equals 180 degrees. The A is 36 degrees plus an angle B plus 90 degrees for an angle C equals 100 degrees. Therefore, an angle B equals 180 degrees minus 36 degrees minus 90 degrees give us the B equals 54 degrees, which is 2 decimal, to the nearest degree, or no decimal place. And then we are going to find the side A. The side A is the opposite of an angle A. We look at the definition number 2 that involving the opposite side. one of them is the sine. So sine of A, which is the opposite of the sine A over the hypotenuse, and A is 36 degrees. So sine of 36 degrees equals the opposite, which is A, divided by hypotenuse, which is C, or 11. Then compute A by multiplying 11 both sides. So A is 11 multiplied by sine of 36 degrees. Put in the calculator to get A equals, and we're gonna need like two significant digits for side A and side B. So A would be 6.5 centimeters. Make sure your calculator is set into the degree mode. Next, we find the side B. Side B is adjacent, so the trig function involving adjacent would be cosine. Cosine A equals adjacent over hypotenuse. Replace the numbers. Cosine of 36 degrees equals the side B, which is adjacent, divided by hypotenuse 11. That gives us the B equals 11 multiplied by cosine of 36 degrees. Put in the calculator, we obtain B equals 8.9 centimeters. Next example, an angle B is 24.5 degrees. And the side C, which is a hypotenuse, is 2.34 feet. Find the side A, which is opposite to an angle A, and side B, which is opposite to an angle B, and then an angle A. Consider the significant digits. An angle B has the accuracy to the nearest tenth of the degree. Nearest tenth. And the side C has the accuracy of the three significant digits. So our solution for A and B would have the three significant digits, and an angle A would contain an angle in the accuracy of the nearest tenth, or one decimal place. To find an angle A, from the sum of the three angles, the A plus B plus C equals 180 degrees. A equals 180 degrees minus an angle B, which is 24.5 degrees, and angle C is 90 degrees. So A is 180 degrees minus 24.5 degrees minus 90 degrees. That gives us A equals 65.5 degrees. Next, we're gonna find side A. The side A involving, this time let's use the trig function involving an angle B. A is adjacent to an angle B. We're gonna use the cosine of the B equals adjacent to an angle B over hypotenuse C. Substitute the number, the cosine of the B, which is 24.5 degrees, equals the A divided by C, which is 2.34. Therefore, the side A would be 2.34 multiplied by cosine of 24.5 degrees. Put in a calculator, that would give us 2.13 feet, which remains the three significant digits. Next one, side B. Side B is the opposite of an angle B. We are going to use the trig function as a sine. So sine of B equals the opposite, which is the side B, over the hypotenuse C. Therefore, the side B can be computed by multiplying C, which is the hypotenuse, to the sine of an angle B. C is 2.34, and angle B is 24.5, degrees. Therefore, the B is 0.97 feet. If we consider the significant digits, we should leave it as a 3 significant digits. It should be 0.97038. So we do the 3 significant digits. Starting from the non-zero from the left to the right, so we add another 0 to consider 3 significant digits.